Hello, my name is Vilashini Subramaniam. Our title for this assignment is Discuss the safety and legal consideration related to the environmental impact of satellite launches and operations, including regulatory framework for minimizing ecological harm. First and foremost, launch site environmental impact. Habitat distribution. Building launch site often requires clearing land which disrupt local ecosystem, harming plants and animals and reducing biodiversity. Safety measures. To minimize habitat distribution, it's essential to implement measures like choosing launch site in less ecologically sensitive area or conducting thorough environmental impact assessment before construction begins. Second, soil contamination. Rocket propellants and fuels used in launch can contaminate the soil with substances like heavy metals and hydrocarbons, posing a risk to soil quality and potential harming local plants and animals. Safety measures. To prevent the spread of contaminant, it's crucial to use contaminant system and runoff controls. Additionally, conducting soil remediation activities after a launch help mitigate potential environmental damage. Legal framework. Environmental impact assessment. Before approving a satellite launch site, many countries mandate an environmental impact of assessment as part of the regulatory process. This assessment analyzes potential environmental effects and suggests measures to minimize them. Permitting and licensing. To conduct satellite launches, launches operator must acquire permits and license from regulatory authorities. These approval typically come with conditions related to environmental protection, safety measures, and compliance with local and national laws. National environmental law. Every country has its unique set of environmental law and regulation that oversee space activities. This law can address concerns like air and water quality, habitat protection, and proper waste management associated with space-related activities. That's all from me. Thank you.
And now we look into the space debris environmental impact, also known as space junk or orbital debris. The impact of space debris on the environment are orbital congestion. The increased amount of space debris in orbit poses a risk of collisions, creating more debris in a cascading effect known as the Cassellus syndrome. This congestion can limit the operational space for satellite and other space missions. And for the safety considerations, risk to operational satellites. Space debris poses a significant risk to operational satellites and spacecraft. Collisions can cause damage or destruction, jeopardizing communication, Earth observation, and scientific mission. And the legal consideration on the space debris is liability. The liability convention holds nation responsibility for damage caused by their space objects. This legal framework establishes liability for space activities and help address issues related to collision and damage resulting from space debris. The regulatory framework that have to do on the space debris are the Outer Space Treaty. The Outer Space Treaty, a fundamental international agreement, established principles for the peaceful use of outer space. It emphasizes avoid harmful contamination and ensuring that space activities are conducted for the benefit of for all countries. And the other one is Space Debris Mitigation Guidelines. The Interagency Space Debris Coordination Committee, that is IADC, and other organizations have developed guidelines to minimize space debris generation. These guidelines include recommendations for spacecraft design, end of life disposal, and space debris measures.
Hello, my name is Navin Kumar Ganesan. My matrix number is B0821100061. Today I am going to discuss about the environmental impact that caused by space launch and operation, which is resource use and energy consumption. The resource use and energy consumption in satellite operations encompass the use of materials and energy across the satellite's life cycle, spanning manufacturing, launch, and operational phases. This involves the efficient management and the sustainability practices to minimize environmental impact and optimize the satellite's overall resource footprint. The safety and legal concession of this is limited resource in space, which is safety concern resource in space such as propellant and satellite propulsion are limited. Efficient use of these resources is essential to ensure the operational life of the satellite and achieve mission objective. The next is the international space law. The international agreements and treaties such as the Outer Space Treaty set the foundation for the peaceful use of outer space. Satellite operators must adhere to these principles, ensuring responsible and sustainable resource utilization. When it comes to regulatory frameworks, first is space traffic management. International collaboration led by organizations like United Nations Committee on the peaceful use of outer space is crucial for developing guidelines and the best practices in space traffic management. These efforts indirectly influence resource use and energy consumption in satellite operation. The next is end-of-life disposal and sustainability guidelines. Regulatory bodies and international organizations offer guidelines for satellite operators on end-of-life disposal. This may recommend deorbiting satellites or moving them to graveyard orbits to minimize long-term environmental impact. So that's all from me. Thank you.
So, the next slide is about the following environmental effect because of satellite launches and orientation, which is ozone layer depletion. And before that, I would like to introduce myself. My name is Darshan Kumar Dayalan and my matrix number is B08211018. So, the next slide is about the environmental impact. Rocket launches primarily cause ozone depletion through two mechanisms, which are exhaust emission, which rocket propellant release hydrochloric acid HCl during combustion in essence to the stratosphere reacting with ozone molecules can destroy them, and also aluminum oxide particles. Solid rocket motors aluminum oxide as a byproduct. These particles can act as a catalyst for chlorine driven ozone destruction. For the safety consideration, actually there got two: depletion of the ozone layer. A weakened ozone layer allows harmful ultraviolet UV radiation, increasing the risk of skin cancer, cataracts, and harming ecosystem. And also the climate change. Ozone depletion contributes to climate change that can affect the temperature profile of the stratosphere. And also for the legal considerations, there got two actually. Outer space treaty. The treaty emphasizes the responsibility of nations to avoid harmful contamination of celestial bodies. And also Montreal Protocol. The international treaty aims to face the ozone depletion substances ODS like chlorine compound used in some rocket propellants. And finally, to minimize this ecological harm for ozone layer depletion, they got three, which are technological advancement, research and development into cleaner propellants and launch, and mission optimization. Optimizing launch trajectories and orbital parameters can minimize emission and environmental impact. And finally, international cooperation. Collaborative effort among spacefaring and nations can accelerate the development of sustainable space technologies.
The next one is manufacturing and productions of satellite. The first one is impact on the environment, resource extractions. The manufacturing of satellites involves the extractions of raw materials which can contribute to habitat disruptions, deforestation, and ecosystem degradations. Energy consumptions. Satellite productions processes including manufacturing and testing often require substantial energy. And the second one is safety considerations. Industrial processes. The manufacturing environments involve various industrial processes, machinery, and materials. Testing and quality assurance. Rigorous testing is essential to ensure the reliability and safety of satellites. The third one is legal considerations. Regulatory compliance. Satellite manufacturing must adhere to national and international regulations governing environmental protections, occupational safety, and product quality. Export controls. Satellites and their components may be subject to export controls and international agreements to prevent the proliferation of sensitive technology. And the last one is regulatory framework. Environmental regulations. Compliance with environmental regulations is crucial to minimize the impact of satellite manufacturing on ecosystem, air, and water quality. Occupational safety standard. Adherence to occupational safety standard ensure the well-being of workers involved in the satellite manufacturing processes. Quality assurance standards. Manufacturing processes must align with quality assurance standards to meet the reliability and performance requirements of satellite missions.